In this video, we're gonna do this integral. We wanna integrate the maximum of sine of x, cosine of x between 0 and 2 pi. We define the maximum of two functions as the the maximum of f and g as it's f if f of x is bigger than g of x for some interval a b, okay, and it is g if it's not f, okay. Sometimes we can do this graphically. So assume that we have these two functions here, okay, and we have this interval. So this is my f, this is my g, f of x, g of x. And on this interval, I want to find the maximum. Clearly, I see that the maximum of these two functions is f of x, because it's f because f of x is bigger than g of x for x is in this interval, okay. If I can extend this interval into some other interval, let's say a, c, and here I see that on this point here, let's call it d, the maximum is going to be g, okay. So on this, now the maximum for this case, f and g is f for x is in AD, and it's g on this interval DC. Okay, so which one is on top of the other? Okay, in our case here we have the sine and the cosine, and we want to find the maximum. Okay, the easiest way is we can solve, or we can graph as I did here. So here I graphed both the sine and the cosine on the same graph or the same paper, and this function here is call it g of x is the cosine, and this one here is the sine. Okay, and now that they do intersect when x is pi over 4, okay, and also after half turn around the circle, that means after pi, that means pi plus pi over 4, which is 5 pi over 4. So here they do intersect again. Okay, now I can see that on this interval 0 pi over 4, the maximum is it's the cosine. Okay, on this interval pi 5 pi over 4, the maximum is the sine. You see the sine here is on top of the cosine. Okay, on this interval 5 pi over 4, 2 pi, the cosine is the maximum. Okay, so therefore I can transform this integral into the following manner. Okay, so I is 0 to pi, the maximum of sine of x, cosine of x dx. So between 0 and pi over 4, and now my maximum is the cosine. Okay, between pi over 4 and 5 pi over 4, and now the maximum is the sine. And between 5 pi over 4 and 2 pi, the maximum is the cosine. Okay, so depending on which interval, like in here, which function is the greater than the other. Okay, we don't give the rigorous definition of the maximum, but for us, which one is on top of the other. Okay, we assume that all the conditions of existence are satisfied in our case. So therefore my integral is this one here, and this is something that I know instead of this one here. Okay, another way to do this one is how do we find this point here, these points? Okay, so here we have to solve sine of x is equal to cosine of x. So this is where they intersect. Okay, I think I did cover this one here. And depending on x on 0 to pi. So we can find all these ones here. After we do that, we can solve sine of x is bigger than cosine of x, or vice versa, sine of x is less than or equal to cosine of x. Okay, we can do this in a table, okay, or we can use the identities that we know. Okay, so here we can transform this one, sine of x minus cosine of x bigger than 0, and we can multiply by square root of 2 over 2 to get into a sine or cosine bigger than 0, and we can solve. Okay, this video has too many ideas that we have seen and you already know. Okay, so you can just rework this one here, find the values of x that would make this one true and this one true. Okay, and you can do that graphically, or you can solve it algebraically by transforming this one into let's say sine of x plus pi over 4 is bigger than 0. Okay, if you do the cosine, if you do the cosine here, if you do the sine, you're gonna have sine of x minus pi over 4 is bigger than 0. Okay, and you can solve from there. We have seen it. Check the videos. I think we have seen that before. Okay, anyways, my integral now, I need to evaluate, and I did evaluate this one. I get I is 2 square root of 2. I'm not gonna do it here, but this is the value that I get. I hope it's right. It's clear to me that it's something that's positive here. Okay, so this is the value, and I think this is all we need here. If you see any errors or mistakes, please let me know. Thank you again.